Welcome to all. This is our next session. In this session, we have study about MIC and its types. That is microwave integrated circuits and their types. In this lesson, we have to study about introduction and what are the types of microwave integrated circuit and what is a hybrid MIC, that is a hybrid microwave integrated circuits, and what are the tools used in HMIC and MMIC, that is monolithic IC also, and the layout of monolithic IC, and what is the mask generating process, then photography of a GAAS and MMIC, then what is the difference between HMIC and MMIC. Okay, nowadays our electronic technology moved towards to small in size and lightweight and low power requirements and low cost and their increased complexity. The electronic technology can be forward in this direction. The MIC technology is a specific answer for all of them. It serves to replace bulky and expensive waveguide with small and expensive planar components. MIC technology gives a little device, so that is it replaces the bulky device and their expensive also, because it is a they are very small in size and low cost and low expensive. MIC technology has advanced to the point where complete microwave systems such as a receiver, front ends, and radar transmitter receive modules can be integrated on a chip that is only millimeter size. MMICs are in millimeter size. It can be also used as a radar system. Then what are the types of MICs? There are generally two types of MICs are available nowadays. One is a HMIC, that is a hybrid MIC, and another one is a monolithic MICs. Hybrid MICs are one layer of metallization for conductors and transmission lines with the discrete components, that is a resistors, capacitors, ICs, diodes bonded to the substrate. So it was first developed in 1960s. Still, they provide a very flexible and cost effective for circuit implementation. These are very flexible to give a complex circuit generation. The transmission line for HMICs are gold or copper, integrated with gold or copper. The next, MMIC, that is a monolithic ICs. These are a more recent emerging development technology where the active and passive circuit elements are in the substrate. The substrate is a semiconductor material and it has several layers of metal, dielectric and resistive films can be used to manufacturing the MMIC. In the first session, we have the introduction of MMIC. These are a single stone, so it does not have any extended matching network like that. Material selection is an important consideration for hybrid integrated circuit. Let's we discuss about HMIC. In HMIC, the material selection is a very important parameter, and the substrate material is a primary important criteria. Substrate material can be generally used in alumina, quartz, and Teflon. First, we say about alumina. We know that alumina is the composite material of aluminum. They are the rigid ceramic materials with a dielectric constant of about 9 to 10. It has a high dielectric constant with a lower frequency circuit, so they are very smaller in size. At high frequencies, the substrate thickness must be decreased to prevent radio loss and other effects. Then quartz, compared to alumina, it has some lower dielectric constant and it ranges 2 to 10, and alumina is 9 to 10 and it is 2 to 10. It provides a very large substrate area at low cost and long rigidity and good thermal transfer, so that are not required. These are the basic design of hybrid MMIC. It can be the interconnection of most transistors, diodes, ICs. Then we come to a hybrid IC. Then come to MMIC, that is monolithic microwave integrated circuit. It's a meaning of a single stone, so it can be manufactured from a single chip of semiconductor. Related to semiconductor material processing and progress of GAS, the device has been led to the feasibility of MMIC. In this MMIC, all passive and active components for a given circuit implanted into the substrate. The substrate and MMIC must be semiconductor material to the fabrication of active devices. The type of device and frequency range dictated the type of a material. The frequency range is responsible for the type of the material. The GIS, that is MISFET, is a very versatile device in more applications because it has low noise amplifier, high gain amplifier, broadband amplifier, mixers and oscillators. That is the GIS MISFET is very useful and versatile device. What are the tools used in this type of ICs? That is CAD, Cadence, ADS, and Microwave Office, then Designer. CAD is nothing but it is a computer-aided designing tools are used extensively for messy design, optimization, and the layout and mask generation process. It plays a vital role. And the software packages are Cadence, that is Cadence Design System, and Agilent Technologies. This is the most powerful technology to prevent to design a MMIC and antenna design also on microwave office and designer and software. The metallized substrate is coated with the photoresist covered with the mask. This is the general layout of monolithic MIC. It has a FET transistor, the MIM capacitor, then resistor and ground plane. These are the semiconductor wafer. This is the general layout of MMICs. Then transmission lines and other conductors are usually made with gold metallization. To improve the gold addition, a substrate is a thin layer chromium or titanium may be deposited first. So titanium or chromium can be deposited first. These metals are relatively lost, so the gold layer just to be made at least several skin depth heat to reduce attenuation. Dielectric flames, SiO, that is silicon oxide, silicon dioxide, and Si2NO4 and titanium O4. Titanium O5. These are the general used dielectric flames. These materials have high dielectric constant and low loss. Low loss. Low loss. After the circuit design, it can be finalized to the mask can be generated first. The beginning process is to form an active layer in the semiconductor substrate for necessary active device. This can be done by ion implementation or by epitaxial techniques, what we can learn in LIC, that's linear integrated circuits. Next, mask generating process, ohmic contacts. These are made to device area by allowing a gold or germanium layer onto substrate. Gold or germanium layer can be first masked into the device's area. FET gates are then formed with a titanium, platinum, or gold. Any one can be masked with this, between the any one material can be deposited between the source, and then we know that FET has three terminals, that is source, drain, gate. The materials titanium or platinum or gold can be deposited between the terminal of FET, that is source and the drain. Next step is to deposit the first layer of metallization for transmission line, inductance, and other conducting areas. Then resistors are formed by deposit resistor. I know that resistors are formed by deposit resistor. And the second layer of metallization completes the formation. First layer is resistors and second layer is capacitors and remaining interconnections. This is the typical photography of GAAs and MMIC. What is the difference between MMIC and HMIC? Monolithic ICs and hybrid ICs. They are fabricated entirely on a single chip, so they are called as a single stone. And hybrid ICs are fabricated by interconnecting a number of individual chips. It is the interconnection of many chips or transistors. The full circuit constructed on a single piece of silicon. Entire circuit of MMICs can be constructed in a single piece of semiconductor. It may be silicon or germanium. The hybrid circuit often ceramic substrate. It carry one or more silicon chip. It also used mixer technology such as GIS chips along with the SI chips. Monolithic ICs are very expensive. These are less expensive. Compared to speed, MMICs have high speed and the hybrid ICs are low speed, and it provides smaller flexibility in circuit design. Hybrid ICs provide greater flexibility compared to MMIC in circuit design. They are very small in size and they are very large in size. Thank you.